Alright, in this video I'm going to add two Cartesian vectors by breaking them into x and y components and then finding the magnitude and direction of the resultant by recomposing the components. So let's call this one 50 newtons at an angle of 45 degrees and 40 newtons at a standard angle of 110 degrees. Alright, so I'm going to make life simple tonight just by describing standard angles instead of using reference angles. And furthermore, let's refer to this one as vector A, refer to this one as vector B, A and B, and I need to first break the vectors into x and y components using sine and cosine. So vector A is going to be 50 newtons cosine 45, 50 newtons sine 45. Vector B is going to be 40 newtons cosine 110, 40 newtons sine 110. And by using the standard angle, in other words, it's the angle between 0 and 360 instead of the reference angles. Reference angles are range between 0 and 90. And I can do a separate video on that. But in the interest of keeping these videos short, there's some background material that I necessarily leave out. So when we evaluate this, and make sure you're in degree mode, this is 35.4. This evaluates to also 35.4 because sine 45 and cosine 45 have the same value. 40 cosine 110 gives you negative 13.7, which means that when we look at the x and y components of this vector, it has a negative x component and a positive y component. This one has both positive x and positive y components. This component is going to be a positive y component. It's going to be 37.6. So what we do is we add the x components of the two vectors and we get positive 21.7. So this is FR for resultant force. Since we're doing a force vector, it can be applied to any quantity that's a vector. And again, these are Cartesian vectors because we're doing them in the Cartesian plane. So these are the x and y components of the resultant vector. So I added the y components, 35.4 to 37.6, and I got 73. So to recompose and get the magnitude and direction of the resultant vector, the magnitude of FR is going to be the square root of 21.7 squared plus 73 squared. That gives me the square root of 5,799.9, which is approximately 76.2 newtons. That's the magnitude of the resultant vector. The direction is given by the inverse tangent of the y component over the x component. So it's always the y component over the x component, and this is going to give us an angle of 73.4 degrees. So the thing that inverse tan will always return is a reference angle. Okay, And so this, the magnitude is not a problem. The problem arises with inverse tan. In this case, it's not an issue because both components of the resultant vector are positive. So the reference angle, this is a reference angle in the first quadrant. It's also a standard angle. But and I could do another video using two different vectors, but you have to look at the signs of the components of the resultant vector to determine what quadrant you've landed in. Because again, the only thing that this is going to give you is an angle between 0 and 90 degrees. It won't tell you what quadrant you're in. You have to look at the signs of the components. And probably another video is doing another two vectors would be suited to give you an example of that.